Hello and welcome back to Finance World. In this video we are going to explore the topic of geometry and the fundamental concepts that underlie geometry. What are these fundamental concepts? First, let us introduce points, which can be plotted on a bit of graph paper as a system of coordinates. Lines, which can also be plotted on some graph paper. They look like this. And angles, which appear in between lines that intersect each other. Okay, we're going to explore something that's called Euclidean geometry, and this is named after the Greek mathematician Euclid. Now, throughout your GCSE and A-level studies, it's unlikely you come across the term Euclidean geometry, but I'm going to address it as Euclidean geometry, as I ought to make sure you understand that there are other forms of geometry which are non-Euclidean. Now, within these Euclidean geometry, there are 5 axioms which are postulated for plane geometry. We'll also explain what plane geometry means later on in this video. So first, let's have a look at the first axiom. Now is to draw a straight line from any one point to another point. So let's picture this. We have 2 points on a bit of graph paper, and we can simply collect the 2 points by drawing that straight line between them. We extend upon this in the second axiom, and that is to extend any finite straight line continuously in a straight line. So note we had the 2 same coordinates on a bit of graph paper, and instead of connecting the 2 coordinates together, we just extend a straight line right through both sides of the points. The third axiom we are going to have a look at is to describe a circle with any center and a radius of any arbitrary length as well. Here we demonstrate the unit circle. It's called a unit circle because the radius has a length of 1, and it is centered at the origin 0, 0. And we can actually describe any circle with any arbitrary center with any arbitrary radius as well. The fourth axiom is such that all right angles are equal to one another. So let us just take a quick example to look at this. Here we plot x is equal to 3, and that's that vertical line. And then we also plot y is equal to 2, and that is that horizontal colored line, and they intersect each other. We can explore the fact that this right angle here is the same as this right angle here, and these 2 right angles are also the same as this right angle created here and this right angle created here, and we're going to prove this later on in the series. Lastly, and this is a bit more tricky, this axiom, and it's a little bit more verbose, so bear with me. It is such that a straight line can intersect across 2 other straight lines, and that makes interior angles on the same side, and the angles are less than 2 right angles. Then the 2 straight lines, if produced indefinitely, meet on that side in which the angles are less than 2 right angles. Okay, it sounds very wordy, so let's just put this on the graph paper so we can pictorially look at this. Here we plot again the horizontal line of y equals 2 against 2 diagonal lines. For simplicity, we have simply chosen y equals x and y equals x minus 2. Okay, now notice that when that horizontal line intersects those 2 diagonal lines, on the same side you have created 2 obtuse angles and 2 acute angles. So if you take the obtuse angle, here we label as A, and you take an acute angle, here we label as B. Now, the sum of these 2 angles must equal 180 degrees. And if they do, the 2 diagonal lines which just got intersected by that straight line are parallel to each other. And that means they'll never meet on this bit of graph paper, and they never will do. Okay, so just bear in mind that this axiom, although it's very wordy, it just explains about parallel lines. Okay, so what is coordinate geometry? A point in a Euclidean space of an xy plane has coordinates x and y. What is an xy plane? So this is where we explain about plane geometry. So we're familiar with this idea. It's a plane where we have a horizontal x-axis and a vertical y-axis, just literally like what your graph paper looks like. That's what this is. That is your xy plane, provided you label the horizontal axis as x and the vertical axis as y. Okay, and we'll be assuming so throughout the course of this video and throughout the course of this series, unless stated or otherwise. Okay, let's have a look at these fundamental concepts in a little bit more detail. First, let's start with points. Here I'm going to present 5 different points, and we are going to plot these on a bit of graph paper. And they look like this, and I have color coordinated these coordinates such that you can look at them and you can see how these are plotted. So the first number is the x coordinate and the second number is the y coordinate, and that's how they are plotted here. Let's have a look at lines. So we're going to plot 4 different linear equations. So these are linear. If you refer back to the linear equations video in the algebra course, you will notice that y is equal to x to the power of 1. It's not x squared or x cubed, therefore it's a linear equation. And let's just draw these lines on this same piece of graph paper, and you can visualize them. They're also all color coded for you, and that's how they look. In the next video, we are going to derive equations of those straight lines that we've just drew, and then we'll have to explore quadratic equations again in the world of geometry, because they bear more meaning than just a simple polynomial on graph paper, rather than just solving an equation is equal to 0. Following that, we have to look at some angles, as that is one of the most fundamental theorems and axioms within the Euclidean geometry. And we'll also explore trigonometry, one of the most fundamental mathematical concepts as well. And finally, we will have a look at calculus. So all this geometry, we can apply some calculus to look at these things in a little bit more depth. What are we going to do? We'll derive some calculus from first principles, and we'll look at drawing tangents to these graphs within the geometry lessons, and we'll also use infinitesimal calculus or differential calculus to derive equations for these tangents as well. So once we go through some of the basics in geometry and calculus, we'll revisit some algebra, and we'll look at solving simultaneous equations again, but this time we are going to solve quadratics and linear equations, and we'll also have a look at special cases of quadratic equations, as quadratic equations pop up a lot of times within mathematics. So if you like this content, please like and subscribe. If there are anything that you would like to know more about, please leave a comment down below. We can discuss this in further, especially around the 5 axioms of Euclidean geometry. If there was anything that was not explained as clear, please leave a comment and we can discuss this further. So for now, please stay safe and peace out.